Let's look at this type of a problem, which is a bit different from what we have been doing all along. Okay, it says consider the following circles P, R, Q. You have to check if you can see the circle P, R, Q, and then the circle Q, R, S, the bigger one. Okay, so the circles P, R, Q and QRS intersect at R. It means they meet there, and Q. And then PQ is a tangent to circle QRS, and then QS is a tangent to circle PQR. And then we are required to prove that RS over QS is equals to QR over PQ. And then thereafter we have to prove that QR squared is equal to RS times RP. So right here, if you check, we are not given triangles to prove their similarity. So on our own, we have to allocate or identify those triangles. So how do we do that? I'll show you simple ways of identifying triangles. Okay, right. So now we have our statement like this. So what you do, you check at your numerators and denominators like this. You move from left to right like this. You check this and look at the angles there. We have R, S, Q, and R. So R appears twice. So we are going to say, let's check if there is triangle RSQ. Okay, we are checking if there is triangle RSQ. Right, and then after that, we're also going to check here QSP, because you see that Q appears twice. So we just take Q once, say QSP. Now let's start with RSQ. Do we have triangle RSQ? Yes, RSQ is a triangle. So we've identified the triangle there. Okay, so RSQ is there. There's triangle RSQ. Okay, let's check if there's triangle QSP. Let's check if there's triangle QSP. QS, then P. Oh, this doesn't form a triangle. So QSP is not a triangle. So QSP is not a triangle. You see that? So we can't use that. So we go to the next step now. It's another way of checking again. Now, if you check here, we move from left to right, and then from left to right. Now, the other way of checking, you move from top to bottom, like this, top to bottom. And then you check here, you take this top to bottom, like this, and then like this. Okay, right. And then if you check, we have RSQ. RSQ. S appears twice, so we just take it once. RSQ. Do we have triangle RSQ? Yes, we have. There is triangle RSQ. Okay, so we're using these letters here on this box, top to bottom. And then now we go to the next one here. There's QRP. Q appears twice, so we just take it once. QRP. Do we have triangle QRP? Yes, we have triangle QRP. Right, yes, we have triangle QRP. You see that? So now we have identified our triangles. So now we have to prove that these two triangles are similar, and then thereafter we answer the questions that follow the same way that we've been doing all along. You see that? Okay, let's just do that now. Right, now we said from here, top to bottom, we have triangle RSQ. We have triangle RSQ, which is this triangle here. Okay, and then from the second fraction here, this one, we say that we have triangle QRP, which is this triangle QRP. Now we have to check the angles, the corresponding angles that are equal. we have to check the corresponding angles that are equal. So now I wanted to emphasize or to show you the method of what? Identifying triangles. Let's go back to our information and try to find out what we can get from the information. Right, circles PRQ and QRS intersect at R and Q. PQ is a tangent to circle QRS. And then if you check there, we have tangents and chords. So it should be tan chord theorem somehow. QS is a tangent to circle PQR. Again, we expect there maybe to use the tan chord theorem. Okay, let's try to do that. Now, let's start with which triangle are you going to start with? Okay, let's start with triangle QRS. QRS. Right. QRS. We have which angles can you start with? Right. Remember that this is my order. You can have a different order of your angles or corresponding angles, isn't it? Right. As long as you know this angle is equal to this angle and you give a reason. So the order I'm giving you here may be different from yours. Okay. Right. So I'll start with angle P and angle Q2. So we can say angle Q2. Angle Q2, we're trying with this QRS, the bigger triangle. So angle Q2 is equals to angle P. Why are they equal? If you check, QS is a tangent to the circle PRQ. So that's tan chord theorem. And RQ is the chord. RQ is the chord. QS is the tangent. So this is tan chord theorem. Right. And then we move on to the next one. The next one will be, we're starting with the angles of what? Of QRS. So here we have S being equals to Q1. Again, if you check here, which one is the tangent? PQ. PQ is the tangent of circle QRS, of circle QRS, and your RQ is the chord there, meaning that Q1 is equal to S. So we're starting with the angles of the bigger triangle. So here, it's just my choice to do that. You can start with the triangle of PRQ. At the end, we're going to get the same answers, right? So angle S is equals to angle Q1. Q1. Again, we're saying tan chord theorem, right? We've proved that we have two pairs of corresponding angles being equal. So now it means the third pair also they are equal. So it means now we can conclude and say therefore R2, angle R2 is equals to angle R1. Okay, third angle of triangle. Right. So those two are equal. Now, we have proved that we have three pairs of corresponding angles being equal. So now we can conclude now and say, therefore, um, triangle QRS is similar to triangle what? Because I want you to take note of this. I'm not going to do all the options or the different ways we can write these angles. Okay, I've said triangle QRS. Someone can say triangle RSQ. Someone can have triangle RQS. You see that? So what is very important is that you make sure that the corresponding angles are what? The equal angles correspond here, right? The Q must go with the P. If Q is position 1 in the first triangle, then P must be position 1 in the second triangle. If R is position 2 in the first triangle, then R must be position 2 in the second triangle. If S is position 3 in the first triangle, then Q must be position 3 in the second triangle. Okay, just do that. And then let's say you have SRQ. If S is position 1 in the first triangle, then Q must be position 1 in the second triangle. R is position 2 in the first triangle, then R must be position 2 in the second triangle. Okay, Q is position 3 in the first triangle, then P must be position 3 in the second triangle. So you see that? So we can have these different representations, but at the end, we will get what? We will get the same answer. So if you have something different here, don't change it. Don't change it. Just work it out till the end. At the end, we must get the same answer. We must come up to the same conclusion. Okay? Right, let's use my arrangement now. So angle Q here will go with angle P, so it's P here. And then angle R here will go with angle R, so it's what? PR. And then angle S here will go with Q, and then PRQ. So we can say now triangle QRS is similar to triangle PRQ. What is the reason? Angle, angle, angle. Okay, see that? Right. We have proved the first part. Now we need to use this similarity statement to prove this. Okay, that's what we're going to do in our next part of the video. All right, let's go there. Right, we've managed to prove that triangle QRS is similar to triangle PRQ. Okay, we have that. So now we can say now, therefore, QR over PR is equals to RS over RQ is equals to QS over PQ. Right, why are we saying that? Similar triangles. Okay, right, remember that QR over PR is equal to RS over RQ is equal to QS over PQ. Right, now what we have here, we have RS, RS, QS, QS, QR, we have RQ there, which is just same, and then PQ, PQ. So therefore, we have our RS is written as RS is fine, over RQ is written as QR is equals to QS, which is written as QS over PQ. Now, what do we do? If you check here, it's a bit different with what we have. So can we interchange QR and QS? Yes, we can do that. We can do that. Remember, we did this when we're doing what? The cross multiplication techniques. So we can interchange QR and QS. So it becomes RS over QS is equals to QR over PQ. So that first question has been done. Okay, right. Now, and then we move on to B. We are required to prove that QR squared is equals to RS times RP. Okay, and we managed to prove that triangle QRS is similar to triangle PRQ. Right, if you check here, QR squared is just the same as QR times QR, isn't it? Right, let me just write that here. So we can have, this is like QR times QR is equals to RS times RP. Right, from our similarity statement there, we can see that QR over PR is equals to RS over RQ is equals to QS over PQ. Why? Because of similar triangles. Right. And then now if we check, we have QR there, we have QR there, we have RS there, we have PR there, which is just RP. So therefore, you have QR over RP is equals to RS over RQ and QR is just same thing, QR. Okay, you see that? And then can we cross multiply here? Yes, we can. So we can say a QR times QR is equals to RS times RP. Okay, so therefore QR times QR is equals to RS times RP, right? Which is QR squared is equals to RS times RP. Right, we're done. Okay, we're going to meet in our next lesson. Goodbye.